Hello viewers, it's time to get started again on the next part. In this part, what we're going to do is get back to the old Leduc tests and get this one to work. In the follow-up test, after we get this one to work, we'll move on to actually running the neural network models on the game itself. That will be our short-term goal for the time being. Once we actually get it to work on the game itself, we'll actually try getting it to train on the game. In other words, instead of just having random players, after optimization we should get good players, at least on Leduc. We'll leave no limit hold'em for later, as it's slow to compile. And right now, let me just talk about it for a bit. I talked about this in the previous video. When you finish with a project, your motivation to do the next step goes down, and it gets the most difficult part is to actually start thinking about what you need to be doing and get started. I'm in that phase right now, and I simply need to put my feet to the ground and try to build up some momentum and, break the ice. It can be a grind to do all of this. In some ways, it's actually easier to do paid work because, you're getting motivated by things outside of your what should I say? Outside of your you have external feedback to motivate you. When you're doing your own projects, you're responsible for everything, and that includes actually motivating yourself to do the project. It can be very difficult to do a project for years and years. Even I haven't been working on Spiral pretty much all the time for the past 9 years. I think I had a skip year in 2019, then I started working on the language redesign in 2020, and that continued until late 2021. And in late 2023, I started working on this again. So there have been like 3 skip years since 2017. And I think that cost me a lot. But even so, thinking about to 2020, it was really hard to get myself to It was really hard to motivate myself, knowing how long it would take to actually get the language to a usable state. And it was difficult to start work on Spiral to begin with. And now that I have all of this, it's difficult to motivate myself to do the project in Spiral. Because I'm not sure whether this will result in actual good agents. The dream of all of this would be for me to make these agents and then for them to give me the capabilities and the power to make money in the real world. The dream is to get power in the real world through the power of machine learning. But who knows whether that will happen. There is an actual business plan behind all of this, and that is to find people who are operating in domains that could be automated and then automate them away. There is a lot of benefit to doing that, and it runs core to the essence of programming. The root of all programming is to find some prey and hunt them down. It's not to get paid work at some company. But it's been so hard to actually get to that point. My YouTube watch hours keep going down, even though I've gotten a decent amount of subscribers. It would be great if community around spiral arrows. I do believe in the language, and I do think it could provide a lot of value to various people, especially in the domain of GPU programming right now. So we'll see how that turns out. I just need to keep working on it. Who knows? I do wish people would interact with me more. You know, you watch these videos, you can ask me questions. And, you know, the only time I got to ask a question was for some of the videos I did in F# back in 2023, but who can possibly remember what happened back then? I wish people would watch these videos and, you know, ask me some questions about what I've been doing. There are probably things you don't understand if you are watching this. And if the video is fresh, I'll probably remember and be able to answer it. Of course, if you ask me questions about video that I made like a year ago, you're less likely to get an answer, unfortunately. And I do apologize for that. Yeah, it's time that we go resume the grind. I think I'll feel better once I implement the actual optimization methods for all of these games. We've come a really long way. I mean, we have the games, and and they're running on the GPU, so that's a very huge thing. And we also have the machine learning library right now. We don't have backpropagation, but we don't need it to begin with. If you wanted to add backpropagation, we could very easily do that. So we just need to integrate these models with the games, train the agents, and we'll be standing on the precipice of the unknown. We'll be able to actually see whether these agents are effective as against real-world players, even if it's only with play money. I'm not sure about letting them play against real money players, but we should at least give it a shot against play money players. I'm not sure whether I'll be able to find heads up sit and go games for play money. Yeah, maybe on PokerStars. We could try that. But if play money sites start giving us trouble, I mean on PokerStars, we'll be able to find somewhere else, and we could just implement a 6-man poker game and train the agents on that. That will give us some action either way. Yeah, every programmer has one great project in him or her, and this project is my own. The programming language, GPUs, GPU games, the machine learning library. This is my great project and my dream. If everything went according to plan, this would be a pathway to the singularity. Just imagine how great it would be if I could win at this, then make some money, then invest that money in bigger GPUs, and use that to make even more money. And then we'll continually invest that in research. I'll be able to make that genetic programming system and discover better algorithms in that case. That would be a big deal. You know, it's actually a pretty difficult thing to make money in the real world, especially if you don't have the gene for entrepreneurialism. Some people are simply good at being entrepreneurs, but I'm not. I'm only good at being a programmer, and that means working for other people. The only solution to this quandary is to get good at machine learning. In other words, get really good at programming so that everything else doesn't even matter. And that's been my approach. I haven't been successful at it, but you'll be able to follow my journey. Maybe I will be successful in the future. Who knows? Okay, enough talking. Let's just focus on this thing. Yeah, let's just let's not think about this test too deeply. Let's just get it to work the way it did before, and then we'll make a new test which gets us closer to what we actually want. Let's see, layers. Okay, let's get to work on bringing that in. Docs and grid. Okay, let me just the first thing we have to figure out is what model to actually put in. Okay, here we have the input. Let's not. We don't necessarily have to put in the same model. Softmax and discrete sample. Okay. Mini batch transfer block. Okay, let's do it. Size block. Size mini batch. Size inner. Whatever, this is always a tensor, I think. Yeah. Okay. This is a great first step because, we've made our first move and that will automatically leave the two other moves. It's much better than, being stuck and mired in indecision. Yeah, we have the input. Now we know we need to. Can just do like okay. Let's do size inner. Oh yeah. We need the ensemble. Okay, so matmult ensemble. Size ensemble, size inner. Oh, it's yeah, not bad. Then we create a model based on the graph, and this is really convenient. We initialize the parameters. Oh yeah, this is definitely not correct. Oh yeah, tensor input. Let me just open the fucking tensor module. Open tensor m. Tensor. int. Okay, this is tensor input, and we have the size block, size mini batch. And the first thing we have to do is actually okay, let's do it. We'll apply the current block block index. Yes, the index of a block in the grid. Yeah, perfect. And that will result in a two-dimensional tensor. Now, instead of going over threads in the grid, we'll go over threads in the block. Threads in block. Tensor input dimension. Oh yeah, and now this is in fact correct. The reason why it wasn't correct previously is because this sync threads wouldn't synchronize the entire grid. It would synchronize just a block. And there is danger that unless we synchronize the grid, we'd get data races. In this case, it didn't really matter, since we are just putting the same input everywhere, either way. But in other situations, it very well could matter. Okay, now blocks in grid, size block, block ID. Let's see, what the hell? Here we're applying block ID. We should have, I mean, we already did that here, so it doesn't really matter. But the mini batch ID, threads in block, size mini batch. What do you think? Size mini batch. Yeah, that's fine. Mini batch ID, tensor input. You know, I don't like this type annotation being here. Let's annotate it properly. Int. Now this is a two-dimensional tensor. Yeah, now this is a one-dimensional tensor, and we can now push the data into it. We just get a pointer at current offset. This turns the tensor into an array, and we serialize the data into an array. We do sync threads here, graph run device. What exactly is the problem? It's taking something as the second argument, and that's something, yeah, would be the ensemble. It's a record of indices. Okay, how are we going to run? Oh yeah, we don't need to run the ensembles ourselves. We can just we just need to pass in the ensemble dimension. Ensemble equals size ensemble. Oh, the serious, the action, printed, tensor extract model. Okay, let's think about this for a bit. Note how awkward this is, and yeah, now we should be able to make it a lot better. Okay, tensor output. Oh, okay, I see. Yeah, we should just get all of the outputs, and for that we need to pass in the output to the node. Let's do this. This should result in in a 2D tensor, and we have to iterate over all of it. Okay, let's see how we did the outputs over here. Here we have the output probabilities. Here we have the output indices. We even have the discrete sample. Yeah, I mean, this is perfect. Okay, this is size ensemble and the size inner. No doubt about that. And we could have more than just a single size, but this is still a test. We're just testing whether this runs at all. And okay, let's see. We have yeah, now we can just extract the output indices and print them out. Oh, of course, before that we can just map over them and we should no longer use tensor input extract, but we shouldn't use graph tensor extract, but input extract instead. Let's see. And this will result in what? Size ensemble, size inner. Yeah, because we are doing a reduction in this node, so it isn't three-dimensional anymore, but two-dimensional. Okay, now here's the tensor output. Indices, output indices. This is what we've put in as the label for the input node. I mean, as a key for the input node. This should be two-dimensional, and this should be an integer. Not bad. I mean, do we want to just print everything here? What's the sample is 4 times 16, whatever. Yeah, I mean, we can just do it. And then it's also printing stuff on the host. Okay, how are the ensembles being applied? Yeah, we have to go over. I mean, we're applying the block dimension, but here we have the ensemble dimension. Do you want to maybe just have the first thread print out everything? That's the easiest way to do it, because I'm not sure how to synchronize the entire grid right now. that's the trouble. We have these sync threads. We could run the model just fine, but it would be difficult to synchronize. Wait, is this really size ensemble? I mean, wait, this is supposed to be two-dimensional, but after if I apply this input scalar with the ensemble, it would be one-dimensional. And the output should in fact be 2D, so this is like the block, size block. Yeah, that's what I think. And why is it complaining? I mean, this cannot possibly be. Yeah, I mean, here we're applying the block, then we have the size mini batch. Yeah, okay. Yeah, but we should still be applying the block, right? Oh yeah, that's right. We have to do two applications. In fact, and I'm just reminded that we put the apply in the wrong place. Whoops. It would be better if we reversed the order of the arguments in apply. Okay, well, let's think about this for a bit. Yeah, here we have the tensor AB and here we have the graph A, but it would be a lot more convenient if we could pipe them together, and for that we need the last argument to come first. And we're going to change all the examples here. So we could do something like, suppose we, whoops, I meant to erase that. Suppose we do this. Yeah, now I can just pipe everything. We don't need these parentheses. I mean, this particular parentheses. We can just do it like this. I don't like having too many parentheses in my code. Yeah, now we fixed all the type errors. I don't need to run this again because I don't think this will break anything at all. We'll do the same thing here. Okay. Oh wait, Wait, what the hell? I got rid of the wrong parentheses. Okay, focus me. I can do this. Oh yeah, we don't need the parentheses because we have this type annotation. So now let's start with the input layer, or rather this will be the output layer, but it's the same thing basically. And we can apply the scalar input ensemble, and we'll also apply the scalar input block. I mean, it's actually pretty annoying to have to put in this input scalar everywhere. We could just, optimize that a little. Okay, let's do some streamlining in the library itself. And this will be the, let's see, input scalar, key symbol T. Okay, let's do ABT. And this will just be the key right now, and this will be the input scalar, and it will be yeah, we don't actually need to put in a type annotation. It can infer it based on the output. I thought that we needed it, but we don't, and this makes things easier. Now we can go over all the examples. Just forget about this input scalar everywhere. We can just apply it to the key. And this is quite nice, I think. Yeah, here we can also get rid of the block here. Not bad. Let me just put in a comment in graph run. Insert the block index to the indices. You know what? Let's do one thing. We'll make this. We'll duplicate this. We'll make this graph tensor extract. Indices. It was so much of wrangling to do this thing in the previous video. Indices, and now we have the tensor extract, and we'll only be passing. I mean, we don't need to pass the graph over here. No, I'm getting stuck again. Okay, indices. And now here we have the tensor extract. And let's we can try folding this in, or rather, no, let's not fold it in. Instead, just remove this. And suppose we do this. This extract graph. But it is kind of awkward. I think the indices and showing formals is not allowed. Okay, and this is just a tiny bit awkward. How about we try putting this in here, and then let's see, F. And then we just do a for indices, which will return T. Oh, I don't think this is a bad solution. We'll do this. F indices, and we don't need to apply the graph because the graph is already applied. Yeah, I see it. Yeah, I think this is the form that I've been trying to figure out in the last video and didn't want to bother. Yeah, you can do it. No, you don't. We don't need to lie about the type. We're passing a proper type into graph tensor extract. Arguably, we don't really need this, but it's not really a best practice to pass in a symbol instead of the actual type. Graph tensor extract. I'm just doing this because I don't want to bother with figuring out which type to apply to the model itself. Yeah, this is model T. I mean, I guess I could have just applied the T variable and have been done with it. And we also need, in that case, I also need to apply the indices here. Yeah, who the fuck wants to do better with that? Okay. And this is how you do manual type inference in Spiral. You take some expression, and at the type level you do this grave operator, and then it will get the expression from the term level and turn it into a type. After which you can apply it to a for all. Okay, not bad. Okay, let's see. We don't need this apply input scale on block. And we can just yeah, it's much more readable. We're just applying the sample and then we're applying the block. Oh no, let's take a look at the stuff here again. In the input we are first applying the block index, and that's fine. And then we are iterating over all in graph run. We're actually in GraphRun, we are iterating over all of the indices in the ensemble dimension linearly. So that's fine. And then if we get the output will now be a three-dimensional ensemble block inner. Okay, it needs to be 3D int. And we should apply size ensemble. So I'm opening TensorM again here, and that actually invalidates what we're importing from ML layers. I mean, it overwrites it. Actually, this isn't such a bad pattern to use, at least in Spiral. You can very easily open a module again. Yeah, I kind of like this pattern. It's actually the first time that I'm using something like this. Now, tensor output. Then we apply the ensemble, and what's left is the block and the size inner. Now we can iterate over all the threads in the block. No, wait, we have to apply the block index actually. Yeah, we have to apply the block index. And no, wait. Okay. A slight change of plans. What we'll do is leave the block as the last dimension, and the ensemble as the inner one. And this will make things easier down the road. So what we'll do now is apply the block and then the ensemble. And it's just a little cosmetic change, but it will make things a lot easier. I think in the previous library, the one that we got rid of in the previous video, and we put in the ensemble as the first dimension, and that could have been travel zone. Or maybe we didn't. I cannot recall at all, and it doesn't matter. But this is much better than the other way around, because it allows us to do this. It allows us to just apply the block index right away. And now we have two-dimensional. And what we could do is iterate in a linear fashion over the ensemble dimension. And yeah, this is everything in this tensor. Now that we apply the block index, is it shouldn't have any data races, so we can just do threads in block. And we can just get the tensor output dimension. Here we have the index. We index into the tensor that, and then we make some fold call arrays. And outside the kernel, we also print out the entire thing. So let's do that. Let's also extract it outside. We won't be using graph tensor extract ensemble. Instead, we'll just print it out directly. Yeah, we know we cannot apply the block index. We just need to print it out. Because, you know, on the host we only have a single thread. I saw on Hacker News a post that the Python interpreter will get rid of the global interpreter lock, so you'll be able to use proper multi-threading in Python. But for now, the version that we have is bound to a single thread, and that makes the programming a lot easier. Now let's see. Oh yeah, I think we should also do async threads after we run the graph. So the other threads in the block can see the data that's needed. Sets the input tensor, sets the input tensor to 0, sends the data into the input tensor, runs the model on the inputs. Yeah, that's perfectly fine. Okay, if there's one thing that I want to do is, I'll just apply the first dimension with 0. Let's do this. The reason why I'm doing this is because all the inputs in the block are this, and they're identical. So we don't need to print out every single block, except maybe to test to see that it's not all 0 or something like that. Okay. Yeah, I mean, this isn't bad. Let's just put some running the kernel. The output tensor is yeah, not bad. And now we can try compiling this, and we'll probably get some, yeah, we always get a type error. Tensor index auto-bound detected at compile time. Oh crap. So it's in apply. Oh yeah, it's something in apply, but what exactly is the problem? You have the size sample, size block, size rematch, size inner. Okay, let me stop here so I can have a breakfast and then I'll get back to this. Let's assume I had breakfast and I figured out where this problem is coming from. It's really telling that we are getting this error at compile time rather than runtime. So the error is here basically. We're passing the sample size while this is expecting an index. So let's do a linear loop linear. That I managed to figure out this error is demonstrating that my brain is working properly this morning. As the spiral build file, and we have another error. The input and the output tensor dimensions have to be equal. Really, where is it? This is in primitives. This is in raw reduce. Really? I'm confused. Why do the raw reduce dimensions has to be equal? Okay, let's just check out what this assert is doing. It's on line 302. Yeah, so here we have the from, and here we have the to. It's first from dim equals to. Okay, right, sorry about that. I didn't say this first. But if we're getting this error, it's probably the case that down. Okay, size inner. But wait, shouldn't it just be like... Oh, so raw reduce doesn't require a two-dimensional tensor. But wait, doesn't raw map require it? No, it doesn't. It requires the last one to be an integer. Okay, I see. Yeah, so we have to make sure that the first part of the dimension is equal to the output. And I'm not really sure whether I put in the correct sizes here. Like, this is size inner, and this will be, yeah, this will be mini batch. The first dimension will be mini batch, the second will be size inner. That's for the output of this matrix multiply. Mini batch inner. So this needs to be mini batch, in fact, mini batch. It's great that we're getting these errors. Back in 2015, I tried building a machine learning library without ever putting these asserts into the code, and I learned very quickly that they are necessary. I think I was doing something like a matrix multiply and the dimensions were wrong and I couldn't detect it. The whole machine learning library wasn't working properly for some reason. But it was getting like... I think I was testing on MNIST and it was getting like 95% regardless. So it was a tough error to figure out at the time. Of course, after that experience, I learned very quickly that we need to put that we need to do dimensionality checking everywhere. It's actually great that CUDA does have kernel asserts. What isn't great is that it's very hacky and built-in. It would be better if it had actual like exceptions that we could throw and maybe even catch. Actually, it will be great. We don't really need exceptions, but it would be great if we could have custom errors. Okay, now let's see. I'm back. I had to take a little break, and now I'm just confused where we were. I think we should have fixed this error. Let's try building it. Oh, and it builds. Okay, not bad. Wait. Okay, I've pinned the tabs at the top. Now let's try running it. Unfortunately, it starts printing the tensor while the kernel is still running. Okay, how is it possible to somehow synchronize? I think I put something in core to synchronize the default stream. Let's see. CUDA core, core CUDA, and here's the device sync. This is supposed to be called outside the kernel. Let's try putting that here. We'll build a file. Now, if I could only hit the correct keys on a keyboard. Oh yeah, now it's printing correctly. Running the kernel. 2460. Right, it's call. Oh, not bad. Not bad at all. This is truly excellent. Let's make a commit here. Pass. And it's better than oh yes, not bad. Now, I think now that we have this as the basis, we can start thinking about actually bringing in the entire game. And what we've done here is huge. I can also wonder if there's a better way of maybe setting the input tensor to 0. But yeah, this isn't bad. It will set them out to 0 contiguously. In fact, picking the data itself should be slower than this. Yes, this isn't bad at all. We've come a pretty long way since we've started this project, and now we're at the threshold of actually making use of these models on the games themselves. We should make the next steps. It's really amazing that we actually added GADTs to the language. I never expected Spiral would have those ever. And existentials aren't even feature in any other language, as far as I know. So that feature wasn't something I even imagined existing before 2024. Okay, I'm going to pause here so I can think about it for a bit, and then we'll resume this. Maybe I'll start the next test, like. Something like this. And now I'll pause. Maybe I'll write something out just to get started. But I want some time alone, so I can plan things out, what I want to do with Leduc. I'll be back soon. I've had the time to think about it. And for the time being, what we're going to do is, let's forget about the Leduc game. It's kind of, how do I put it, not really well motivated at this stage to try to rewrite parts of this. What's really important is that once we have this, that we be able to actually see the training progress somewhere. So for that reason, it makes sense to actually start work on the front end first. And once we have a front end, we'll have a target for which to set our goals in the back end itself. It's even though we've done something similar in the F# series when we worked on implementing counterfactual regret optimization for Leduc. Back then, I think we also started off with a front end and not the back end. On the back end, we had to deal with a bunch of problems, and unless we start with the front end first, we'll be doing a lot of guesswork. So for that reason, let's focus on not on this, but on this. We'll illuminate. Having a front end will illuminate the path forward for us. Oops, what did I do? CV. Leduc train. And this will be a bit fun. It will allow us to decide what all the parameters should be, where we should store all the training data and so on. I think the first time we run it, we'll have to do something to initialize the GPU memory. And for the Leduc, I don't feel like actually saving any of the training players, but when we come to the no limit hold and gain later, we'll actually have to do that. We'll have to do it all in turn. Okay, let me think. Let's get rid of all of this. Now, let's actually run the game. We'll add a new tab here. No limit not no limit hold'em, but Leduc training. We'll also add AI to the list of players. Of course, we'll have to modify the play section and not just we want, instead of just implementing the training module, we have to add it in the play section so we can actually run the neural network model. And in fact, we'll do the training last. We'll first implement the capability to actually run the neural network model. Okay, how about we start off by adding a new tab? Okay, let's unpin all of these. We don't need them. It's been a while since we did any TypeScript last, and it's very good that we're doing that, since it's definitely proof of progress. We've been buried in backend code, but now we have everything that we need. We'll be able to just go forward from this point onwards. let's think. Let me just close the balcony door. Sorry about this. There was a vehicle outside outside my room, and now that I closed the balcony door, hopefully the noise from the outside shouldn't be noticeable anymore. Okay, yeah, this is running. Here you have the indexed ts. And this will be Leduc. Okay, Leduc train, Leduc UI train, Leduc UI train, and we'll import that from Leduc train. Okay, so what we have to do is come up with the top level component. Let's see, Leduc UI train. Okay, here we have the Leduc UI here, and we'll copy this into Leduc train. For now, let's just get rid of this completely. We don't need this stuff anymore. Okay, for this stuff, I mean, we're going to leave it out, and this will just comment out. The UI state, we'll get rid of this, and we'll set the UI state to an empty record. We'll later fill in the types as we need them, but for now we just need to do an equivalent of the hello world. Let's return some HTML. Return HTML hello. Now suppose we go back into the browser and restart this. I mean, what's happening? Oh, I think I forgot to rename it properly. Leduc UI has already been used in the registry. Yeah, well, Leduc UI train. Or maybe Leduc train UI. And let's see, Leduc. Oh yeah, I like this. Now let's try running it again. Now it loads, but we are still missing the Leduc train tab. So let's see, why is it missing? Leduc train. Oh yeah. We need a SL tab. Leduc train. Yeah, perfect. And why is it not showing hello anywhere? Leduc train. Okay, let's do maybe B hello. I have no idea. Let's open up the browser tools. I mean, we already have. That's this tab to the right. And then if we select the element, tab group body, and let's see, what exactly? This is the games UI, shadow root, base. Okay, where is the... I'm kind of confused. Shouldn't this be in group body? Leduc train. So it should be projecting this. Leduc train UI, shadow root open, and be hello. And it's not showing up for some reason. Okay, I mean, let's see. Here we have the Leduc. Let's check out the styles. Host, display, flux direction. Let's set some of the styles. Flux direction, box size in border box, height 100%. Okay, let's can we set the background color? Background color red. Yeah, I mean it's literally not showing up. That's the problem. I mean, is there something wrong with the index? And how do we set the default? Oh yeah, let's make this deactive tab. ASD. Oh yeah, here ASD shows up, but over here for some reason nothing shows up. And I mean, okay, suppose we did this SDF and commented this out. I mean, shouldn't something show up now? No. Oh, this has a dash and this has an underscore, for fuck's sake. I keep making the same mistake over and over again. Okay, now let's see what happens. Yeah, great. Now we see the background color. Okay, we can get rid of the red background color. Oh, not bad. So this is a great first step. What we're going to do next isn't necessarily what we should do, but it's what I want to do. We're going to check out the charting capabilities for Shoelace. I think it had a chart in it somewhere. Let's see, chart, Shoelace style, chart. Oh really? It doesn't have any. I could have sworn it did have a... I guess we'll have to get one from somewhere. Oh, it was such a pain in the ass trying to install this library. If I could do it all over again, I just get one from a CDN and not worry about it. I mean, the installation for this is so complicated. You even have to copy some image files manually into the bundles folder. Okay, where do I get the chart? I guess that's something we get. Web components chart. Apache ECharts. And open source. Install from npm install ECharts. Okay, I guess we'll try this one. I mean, whatever. It probably has line charts in there somewhere. Whatever. We'll import all of the ECharts functionality. Who cares about the bundle size? We're using this locally anyway. Let's do an npm install. We'll close this for now. We need to open the terminal, which we did just now, and I guess, yeah, npm it has only like 2 high severity vulnerabilities. I guess that's JavaScript for you. It has vulnerabilities everywhere. ECharts init my chart set option. You know, even though I've installed this thing, doesn't it have some charts which have proper web component interfaces instead of having to render it all using JavaScript? Okay, let me pause here. I'm going to do some research on charting packages. We got to this, but it's like the first thing that came to us. Maybe there's some more modern stuff that we should be using instead. Let me pause here, and I'll get back to you with the final decision. In fact, maybe I'll just create a simple example on my own and then get back to you. It's not really worth it for you to watch me trying to, you know, try out these libraries. Okay, let's do this. I've failed you today. I was supposed to go out, but then I decided to sleep in, and I ended up sleeping for way too long, until 11:30 a.m. And right now it's 1:30 p.m. and it's only now that we're going to start. So let's do it. Yesterday, what I ended the session on, the note that I ended the session was that we were testing out the ECharts library, and we had some issues with the tooltips going off the screen when the chart was very large. I figured out some ways of controlling that. For example, here we have the tooltip confined true, and that helps things. Let's run it. To admittedly, it would actually be better if it went off the screen. You'll see what I mean quickly. Yeah, right now it's kind of putting it over the entire chart. I have no idea why the tooltip is so damn long. I mean, so damn large. Okay, let's make it a bit smaller. Like, let's make it 60. Yeah, now it's a bit better. And as you can see, it's no longer getting drawn outside the box. But that's not necessarily a good thing, because once we once we hover the cursor over the bar, it pretty much hides the entire chart. So once we disable that, you'll see. Yeah, it works very nice. And this is still pretty poor behavior. And yeah, I haven't really figured out why the library cannot get the DOM width or height. So yeah, that's supposed to be our goal, our first goal for the day. So let's figure that out. ECharts in DOM web components. You know what? I think I'm just going to like open an issue. Avatar. Primary visible emails. I guess I'll add this one. And confirm. Yes, this is fine. Verify your email address. Verify email address. Okay, Universe 24. The super early bird sale. What the hell is this? I guess this is some kind of a conference. I have no idea. Mod Blazer. Okay. I guess now we had some kind of feed. This is my first time seeing something like that. I'm not sure why I'm subscribed to this, but whatever. Conf UI. Anyway, let's just move on. Yeah, what I want to do is go into the ECharts repo and ask them about this. We're going to provide some, some screenshots. Let's see. Where was I? Okay, let me just do a search for web components. Okay, let me just paste this entire thing here. Can get the width or height. Okay, we'll open an issue. I have no idea why I'm the first one running into this. Oh, find in examples. Oh, okay, this will be useful. This is like a basic line chart. Oh, and the stack line chart is exactly what we want. Okay, and it also has TypeScript as examples. Edit code, full code, series, data. Get element by ID. Official editor. Okay, let me pause for a bit while I fill this out. Instead of opening a GitHub issue, we're just going to make a Stack Overflow question. But right now I'm looking at the examples, and this is like the basic bar chart. And what I want to do is try to paste in this. And what happens when you do this? Oh, you can tell that it's actually showing up really nicely here. But in our own UI, you can see that the tooltip is very messed up. I have no idea what's going on. Okay, so that's something to think about. Okay, maybe making a minimal reproduction wouldn't be a bad idea. Full code. Option preview. Okay, never mind this. What is this JS fiddle? It's never worth it to whitelist. I remember, there was a site I was browsing, and it was begging me to turn off the ad block, and I relented and turned it off. And what happened was that the ads were full of granny porn. I immediately turned it back on. Let's see. I guess we'll be messing with ECharts for today's session. I want to see how to make it work. Oops. Okay. JavaScript, no library. Frameworks, extensions. Does it have lit maybe? Oh, it has processing JS. It has a bunch of stuff, it seems. jQuery. We can always just import a lit from a CDN, like this thing here. It's not a big deal. And how the hell do I run this? Oh, here it is. Okay, if I run it, yeah, you can see how the tooltip is not supposed to take up the entire screen. Okay, I guess we'll do maybe a little example. Let's see. Who knows? Maybe we'll go with a different charting library at the end. Right now, I'm not really sure whether we're doing something wrong or whether the library is broken. So let's see. Okay. Okay, how do we import a lit? Okay, lit CDN. ECharts. And how do I save this? Save. I guess this is the URL. Okay, I'll just put in a link for this here, so we don't lose it. Okay, here we have the div chart container, and we just have to. Actually, no. We're going to make. We're going to put in some kind of a lit element. Let me just take a short break. Let us resume. Yeah, this is fucking JavaScript, and I really want TypeScript. Language. Okay, here we have TypeScript. Now let's import lit. Getting started. Fuck it. Just give me. We don't have to put it here. We could just import it directly from the script. I mean, okay, whatever. Lit import lit core main.js. Is this running? When I try to import this, it's not running, and is there some kind of an error? Window add event listener. What the hell? Shouldn't this be listener? Where the hell is this getting executed? Okay, never mind JS Fiddle. Do we have something else like Stack Blitz? Stack Blitz. Okay, now let's make a new project. Does it have a lead project somewhere? Angular U by Quadrant API. Oh, thank you. Okay, how do I say this? With the JS, with. Okay, it seems like this session is going to turn into a big time waster. Yeah, maybe there's something wrong with the library itself. I don't know. Okay, let me pause here. I don't want this video to be about me spending like 4 hours trying to get this charting package to work. I'll be back soon. What I've done is installed ECharts in the terminal. Now we're just going to paste the stuff that we had here the stuff that we had into our own file into it. Let's see. What's this declare global? Let's also copy paste the imports. Never mind this. Let's just erase this. Can I? Fuck it. There's no. Whatever. We don't need to remove it. It's too much of a hassle. And let's do this. Okay, remove. Okay, not bad. Now, I guess everything compiles. Oh no, what exactly is the problem? My element and Vite projects have instead of okay, here is diffy and my element, something should happen to it. Let's see, where is the render function? Okay, let's comment this out. Return hello. Let's get rid of this. Oh, these fucking charts. Why the hell aren't they working? Style. Maybe we could, okay, let's make the body take up the entire, like, where the hell is the index? What a pain in the ass. Body. Okay, finally something is happening. Okay, we finally have this running, and as you can see we have pretty much the same issue of the tooltip being too large, going off the screen, and so on. Okay, so we should save this. And that having said, what if we made this maybe a light down element? Okay, let's can I guess it's saving automatically. And ECharts with problem. Let's name the, yeah, we'll name the okay, so what exactly do we do? I think there is an option that I've never really tried, but it allows you, instead of putting everything into the shadow DOM, it allows you to put make the elements light DOM, light DOM. Working with the shadow DOM. Query all. Customizing the render route, create. For fuck's sake, who's going to figure out how to do this? I forget JS fiddle. Oh yeah, what we could do is maybe make some kind of a chart element. I mean, for comparison, instead of putting that in my element, we have the okay, so okay, let's try commenting this out, and we'll copy this. And this, we'll make the chart container window query selector, what's it called, my button or something like that, my element. Okay, window get what, get computed, get
get by ID, get ID, or maybe document get element by ID, and my element. Yeah, perfect. Or actually, it shouldn't be. Fuck it. Query selector my element. Yeah. Okay, good. Element or null. And we'll make this const chart set option as HTML element, okay, chart. Yeah, okay, no, not bad. Now we aren't even registering this element as anything. We can comment out the delete stuff. And if we body my element. Okay, let's make my element width 100%, height 100%, background color red. Oh, I see, so it's very small for some reason. Oh yeah, now it shows up correctly. And okay, instead of making it an inline element, let's copy this display block. Oh yeah, now it's much better. Oh, so yeah. So there's definitely something wrong when using this in a web component. The tooltip actually is perfectly fine right now, but in a web component it isn't. Okay, suppose we could comment this out. Yeah, now it's messed up. Okay, I suppose we get rid of this host thing. Okay, and height 100%, width 100%. Yeah, it's extremely messed up when it's used inside a web component. Okay, with this, I think I can finally open something like at least a Stack Overflow question. Before we do that, I remember, when I was doing for ECharts with lit, web component wrappers for ECharts, and let's see, what exactly is this supposed to be? LNTS. I just want to see whether there's some kind of a trick to only teachers. Delete ECharts. Display block, height 100%, chart with height. No, there is a turning insight, as far as I can tell in this. Maybe I missed it, but okay, let's also can I open the let's open the DevTools. Oh, it's broken as fuck. But suppose we okay, there's nothing in the console that's really popping up for me. Okay, well, I guess we have enough to actually open a question. Let me do that. I'll pause here while I write it out. Okay, we'll open this as a bug report. And what I'll do for the time being is forget about this library and look for something else. I guess we can consider this a failed experiment. Okay, let's try out Chart.js, whatever. Don't put me here. Chart.js. Okay, we'll try downloading it from npm Chart.js, npm ECharts.js. Okay. Whatever. Let's close this. npm uninstall ECharts. npm install Charts.js. Oh wait, what did I do? Really? Chart.js. It should be singular, not plural. Okay, we have it. Yeah, not bad. So the only thing left is to actually try it out. We'll have to look at some examples. We'll get rid of ECharts. Okay, let's getting started. Create a chart, canvas, ID, my chart. Okay, so we have to, I guess, create a canvas. It's actually pretty similar to how ECharts works. We just need to have a canvas on the page. Okay, how do I get that from an npm? Okay, here's the npm version. Run npm install. Import chart from Chart.js auto. Div and canvas. Async function. Okay, we can work with this, no problem. Let's think about it. Where's the render function? Okay, here's the render. We'll make a canvas. Thank you. Okay, here now we have the reference for the canvas. Okay, div style with I mean, we already set it to take up like 60/60, so that's fine. Acquisitions.js. What's this acquisitions thing? This is the file that we see here. We don't need it. What we do need is to actually import the chart from Chart.js auto. I guess this is a default import. Now we have this. Okay, let's just go copy paste this. We don't need this anymore. I don't think we need a resize observer either. We can just put in the chart container. I guess in this case it will be the chart canvas, I think. Get element by ID acquisitions. Let me just think about it. The acquisitions, yeah, that's the ID of the canvas. New chart container. HTML element is not assignable to parameter of type chart item. HTML element is missing the following properties from the type HTML canvas element. Okay, we'll just change this to HTML canvas element. So it maps the labels and the data into the chart. Okay, I see. Oh yeah, this is very similar to how Apex charts worked. I honestly don't mind using this library at all because, because since it's popular, it's probably well maintained to begin as well. Okay, let's just indent this. Oops, why the hell? Should I indent this also? Okay, now I understand where everything is. Okay, I saved it. Suppose I tried pressing Control Shift F. No, wait, that's find. What exactly is the format document? Shift Alt F. Okay, Shift Alt. I can just click this, and I see no change. Suppose I. Oh, okay. So it formats it nicely. Oh no. Okay, let's see. I guess we can try running this. Let's do that. Oh, nice. This one actually works properly on my browser, and you can see the tooltips are not going off screen or anything like that. We'll go with this charting library. This is a lesson that I already know well enough. You try a library, it's popular, but it doesn't work. So I opened the bug report and then I moved on to something else. I guess I should have gone with the number 1 library instead of the number 3 library. But I kind of discovered ECharts first, so I just went with it. I guess it's all a part of necessary research. Yeah, nice. I guess over here they're just using a screenshot instead of running it in the documentation directly. The logic goes to volume around Chart.js. Real data. Okay, we're going to have to figure all this out. I'm kind of wondering. Let's take a look at the line charts. Area chart, line chart. What I need is a line chart. Oh, okay. Here is a live chart. It's running directly on the config type line, data, labels, utils, months. Okay. Let's see. I guess we'll comment this out. And what I'll do, let's put the data in. I wish they didn't do this utils months. Config type. So okay, let's do this. I like how user-friendly this chart is. We didn't have to mess with the resize observers or anything like that. Config. What's the problem? Chart registry. What the hell? I mean, yeah, we don't have the fucking labels. Okay. Months in a year. Ah, fuck you. Just give it to me in alphabetical order. We'll just copy paste it, whatever. Okay, I'll pause. Okay, here we have them, and it's still complaining about something. What is its problem? Okay, let's just inline this. So after that we'll hopefully get a better type error. Oh, the type error, I mean, it didn't go. I mean, it really went away once I put in the config, really? I guess the type line was the issue. It probably converted it to a string instead of a string literal in the type, and then got confused. Whatever. Okay, now let's see what happens when we go back to the UI. Oh, nice. Okay, does it have something like a stacked line chart? Bar chart, area chart. ECharts had a lot of very nice charts in the examples. Okay, let's ask Bing. Does Chart.js support stacked line charts? Okay, let's see what's going on here. Responsive true, tooltip mode index, data sets. Maybe I could add some more data sets. So let's think. Let's try that. This is like my first data set. I guess we can do like a second one. My second. Okay, let's make this first, and we'll let's do map x equals x plus 5, and okay, this is the border color. Let's make it a bit more red. Now, okay, let's see what happens in the UI. Oh yeah, nice. Second data set. I mean, this is perfectly fine, I think. Labels come separate from the data. I mean, I thought it would be, I thought that color difference would be more pronounced. Let's see, what happens if we do this? Wait, I forgot to save it. Oh yeah, now it's a bit more gray. Okay, I see. Suppose we did this. I accidentally started this, but never mind. I also forgot to save it. Oh, great. Yeah, now it's very dark red. I mean, I don't really need anything else from my charting package, so whatever. I guess we can use this. I mean, there's not much in terms of examples here. We have the basically line chart. I guess a radar chart. Scatter. Polar area, mix chart types. You can put the type in the dataset. Type bar. Line dataset. Oh, okay, I see. Okay, I see. Donut at pi, donut and pi, I mean. Okay, this is the chart is a lion. Bubble chart. I guess this one doesn't have labels. 3 dimensions of the data at the same time. Oh, I see. The size of the bubble is the third dimension. I see. bar chart. Begin at 0, true. I mean, I'm just like playing around and looking at what's going on. This feature is implemented by the filler plugin. Okay, I think I kind of get it. I think this chart is not really as feature-rich as ECharts. ECharts. Let's take a look at the examples. You can see it's this one has a lot of wild things. Confidence bands. Yeah, this one has a very rich example page, but the Chart.js is a lot more basic, which is arguably fine for our needs. Well, it really has a lot. It's very impressive, actually. Oh, it also has maps. I mean, this charting package is very next level. I guess I hadn't made a mistake in wanting to go with this first. Oh, try the globes. Yeah, it's very impressive. Try the scatter. You know, this makes me wonder which charting package is the second most popular. Okay, let's do npm Chart.js. This one is super popular. D3, ECharts. Okay, let's do this. ECharts. Maybe that's the second most popular. But it was kind of buggy when we were using it with Blazor, so it has 800,000 weekly downloads. 800,000, 3.3 million, and 850. I guess ECharts is like the second most popular now, and Apex is third. What about high charts? Oh, this is like the second most popular. It has 1.2. And this is based on SVG, which is slower than writing on a canvas. Okay, let's take a look at it. Whatever. Svelte integration. Okay, I guess this is like a paid product, but it also has a demo. spline, logarithmic axis. Oh, I guess this one is also pretty impressive. Audio charts. Okay, that's something new. Spline updating each second. It also got 3D charts. View Chart.js. Okay, I guess it's just these four: Epic Charts, ECharts, Chart.js, and ECharts. Stock charts. Yeah, this is also an impressive library. Okay, but I don't feel like messing with this anymore. We're going to go with Chart.js and its basic charts, simply because they work and we don't need anything more than it. Now, okay, let's commit to this. We'll go with the we should also open an issue. EChart. And oh, okay, I'm glad that this is done with. Now we have a proper charting package. I have no idea what this tension is supposed to be, but never mind. Maybe it's the width of the line. Or maybe how wavy it is. Okay, Okay, let me just pause for a bit here and think about what we want to do next. I should put this video on the timeline and yeah, I don't feel like talking. We'll do that very soon. Let's resume. Today it feels like I'm just wasting time. What exactly happens if we leave out the labels? Oh, it doesn't work at all, unfortunately. Okay, let's see. I mean, does it have to be an 01 labels number? I guess it can be any. Okay, let's do. Suppose we put labels now. We still get a problem. Just 0 and 1. Yeah, we don't need the label for the other axis, otherwise it won't work. But that's fine. We can just generate, you know, an enumeration for all the data. What I want to do now. Okay, let's add a button to this. Button. Click. This add data. Add data. And then what exactly should we do? Chart container, new chart container, type data. Okay, we have to figure out how to actually update the chart with new data here. Let's just ask Bing, who wants to mess around. How do I add data to an existing chart in Chart.js? Chart data labels push label. New data. Okay, I see. We have to call chart update. Updating options. It's possible to update the title. I guess that's easy enough. Okay, so for now, let's see, we should save this chart somewhere. Okay, let's do chart and let's see, let's do this chart equals, yeah, this is fine. Okay, now if this chart, then what? Chart data labels, push label. Okay, first we need to this chart data label push data, and then data sets for each X, I guess data push. Okay, let's do. How do we do a random math random? I guess let's make it 100. Actually, let's make it a linear interpolation between okay, 30 times L plus 100 times 1 minus L. And that will linearly interpolate the data point between 30 and 100. And okay, let's make it this like this, but we'll also add 10 to it, like plus. I mean, no, wait. Okay, this is fine. And this will add data to all of the data sets. Now, add data point. And maybe we should make this SL button. And let's see, SL button. It needs to be closed. Alright. We'll make this a Shoelace button. Now, let's give it a try. Add data point. But we forgot to call the chart update. This chart update. What's this update mode? Well, whatever, we'll figure that out later. Let's refresh. Oh, nice. Yeah, I like this. Okay, so what's that Chart.js update? What's I mean, it does. Why? Why is it making things up? Chart.js, journal, configuration, update. Adding and removing data. Oh, okay, so that's where it got the... what's this responsive? Well, we'll figure that out later. None. This controls the animations. But, okay, you know what? Let's just do Control and then left click. And it will bring us to the type. And then we have update mode. So this is just a string. Resize, reset, none, hide, show, default, active. Oh, okay, I see. And it can also take a data set index. I'm not sure what that's supposed to be. So, updating options. It can also be logarithmic. Now, what's this new ID? Okay, let me just try one thing that I'm interested in. Instead of interpolating them between 30 and 100, let's also add the index to the mix. And then index. Let's make it 5 times index plus. And then it should uptrend. I mean, where's this? Oh, right. I'm thinking about the wrong index. This is the index of the data set. Instead, what I want is the data set length. Okay, let's do this. This chart data labels length times 5. So something like this. No, let's give this a try. Yeah, now it shows a clear uptrend. And what I wanted to see whether the chart rescales automatically, and it does. Yeah, this is nice. I like this. Okay, I guess that takes care of that. We can now update the charts properly. That will be useful. So, okay, let me pause here so I can think about what the next step should be. Okay, I had the time to think about it. Before we can even get serious, let's do some testing. Instead of updating chart directly, we should have labels. Oh, labels, and this will be an empty array of numbers. Number. I guess this should be data sets. Wait, data. I mean, okay, I see. So this will be an array of arrays of numbers, and we'll make it like, okay, for now let's just say it's 3 arrays, or maybe even 4. Okay, let's make it 4. And let's do the these labels push. Okay, let's also make this I. Let's make it the label index equals 0. Oh yeah, and I shouldn't have gotten rid of the chart. Okay, now we have the chart. I'm just wondering, instead of having the data be on the chart, it should be in the state. Okay, so when it comes to the UI state, I want to make a distinction between the public and the private state. The private state will have the actual labels on the data. And the public state will be the new data that will be coming from the backend public. Let's see. I guess it should also be the label index. And the reason why we want to simply get the index, I mean the length of the labels array, is because we want to decimate the array once it grows after to a certain size. I've been thinking how we want to do that, and we'll just filter out every odd element in the first 40% of the array after a certain point has been reached. So we have the label index. Let's make this new labels, new data. And as you can imagine, this will go into the chart. So, you know, I'm kind of not even sure whether we need to make a distinction, but whatever. I mean, the previous state could just be in the component itself. It won't be shared anywhere. I'm not sure what's right and what's wrong. What's right and what's wrong here. I mean, okay, let's make it like this. Still public. And let's make the label index equals 0. Oh yeah, it isn't an equal sign, but this thing. And new labels, new data. Those will just be an empty array. and we need to put a colon instead of a semicolon. Okay, and I guess it should also have like 4 empty arrays for now. And labels. I mean, I'm kind of uncomfortable with this definition, even though it is the most sensible one. What the hell? The public UI state. Okay, let's make this number of let's make this ensemble size ensemble number size ensemble 4. So okay, so I mean, is this really right? Is it really right to do it like this? Shouldn't it be? Yeah, instead of maybe an array of arrays, what about array of, well, like an array of tuples? Yeah, that might be a bit better. But you know, this is in fact. Yeah, I mean, I'm just debating whether I should use a structure of arrays or array of structures, and it's probably better to use an array of structures. So, you know, if we're actually getting new data, it will be something like this, and then, whereas another representation that could be possible is to just do 1, 2, 3, 4, 5, 6, and 7, 8. And I think the first one might be a bit easier to deal with. Because if there aren't any inputs, we could just do this. And the problem is solved. Okay. So here we have the size of the ensemble. Oh god, this is such a fucking eyesore. Let me just get rid of it. Background color red. We don't need this anymore. We've gotten rid of the. We've resolved the issues with the charts. And we don't need a label index. That will be private to the backend. What I want to introduce when it goes to the front end and the back end is private and public states. Previously, I've designed it so all the data is shared, but right now we cannot do that anymore because it will be too much to keep sending the neural network data between the front end and the back end. And since we are making that change, we might as well formalize the states being public and private. UI state public. I mean, let's do it like this. So it's not like this is a public state anymore. Maybe we should just think of it as sending messages back and forth. Yeah, it's a bit difficult to accept, but yeah, instead of making this UI state, we should be thinking about the messages that we are getting and sending from the back end. Ah, fuck's sake. Update. Why is this happening? Update. Chart. Let's do this. Update chart. I mean, it could also be something else, like you know, a tuple. Okay, let's do something like this. We'll make it update chart, and we can think of it as a message being sent from the back end to the front end. We'll be sending messages to the front end and getting messages back. And do we really need the ensemble size? I mean, yeah, we do, because we need to initialize the different data sets for the chart. I guess, you know, we can yeah, you know, yeah, the program design isn't really easy. And it's like fucking 40 degrees in this room, so I'm sweating like a pig. I really don't feel like programming. Whatever. Okay, let's make it. Okay, the biggest issue that I have is how to set the ensemble size. What exactly do you want to do about this right now? Okay, I don't need the labels anymore. First data set. How do we initialize the chart? I have an idea. You know, but now right now we'll be sending messages back and forth, and I have no idea where to exactly even start with this. Oh my god, this is so fucking annoying. Okay, let me pause here so I can think about it. I got this reply to that issue that I opened, and it seems legit. Yesterday I noticed that when we change the background color of the div container, it also changes the background color of the tooltip. But I didn't put 2 and 2 together. So what we're going to do is go back to ECharts. Okay, let's see. UI state. For fuck's sake. What's going on? Let's open the file history. Okay, let's just copy paste stuff one by one. Chart, ECharts. Yeah, I mean, let's just copy paste everything. Who cares? I also had time to think yesterday what I want to do about these graphs. It's quite strenuous trying to figure out how we're going to manage them, because they're all completely imperative in nature, and kind of wrecks the overall design to even have them in the code base. Okay, first we actually need to install them, so let's do that. Let's see. Actually, first we need to uninstall. Uninstall Chart.js. Install ECharts. And whatever. Now this should probably run. Ctrl+Shift+B to run everything. Yeah, now we have the same issue, but once we fix the CSS styles, let's see. Chart container. Oh, now let's put a class equals chart container. Yeah, perfect. But now if we restart, yeah, perfect. Oh, this is wonderful. Now we can make use of ECharts. What I want to do is try to factor this out into its own component. We're going to manage all of the chart updates using effects. And in particular, we are going to have the inputs initialized. But for that, we need to write a wrapper. I'll show you what I mean. Let's see. Leduc, okay, Leduc chart. Let's make it training chart. Okay, something like that. Training chart. Let's forget all this. We don't need that much padding. I suppose this could be a block. In fact, we're yeah, we don't even need to get the reference from a div. We can just yeah, we can just set the host to block and the height and width to 100%. So something like this. And now we don't need the input reference. Let's see. What we'll do. Chart container is this, so we don't even need the if statement anymore. Ctrl Shift F, no, not that. I mean, Shift Alt F to format the whole document. Now everything is indented correctly. Okay, so we can just rename this to this. And what we'll do is, let's see. We don't need the input reference. Chart, let's make it a chart. And we'll just do training chart. Training chart. In fact, we can just, yeah, we want to have multiple charts, so we can just do training chart. We can control it using CSS elements like this. Now, okay, I guess this should be fine. So let's restart this. And something is going wrong. Okay, background color red. So okay, so it has a width and a height, but the chart isn't showing up for some reason. I guess we could put it in a div. Okay, let's do a render. Render return HTML, basically just an empty thing. Okay, let's do a div then, for fuck's sake. I wonder why the current I want to understand this a bit better. Shadow root open. Oh, there's nothing in the shadow root. Okay, so I think I understand. It's not in the shadow root, but it's in the light DOM. So what we could do is simply maybe put in a span. I mean, not a span, but a slot. Is it like this? Or... Oh yeah, it was like this. Where did I put in... Yeah, let's get rid of the background color. Yeah, perfect. What the slot does is simply inserts the light DOM elements into the shadow DOM. Yeah, I very much like this. Okay. Yeah, in the future we might be changing the options. Okay, here we have the sales and the bar and the data and the x-axis. Okay, so this doesn't have the datasets field. Instead it has something else. And we're going to have to repeat the exercise from yesterday, which is put in a button and then have it add some elements to the chart. But okay, yeah, let's close this here. It shadow. Okay, okay, what is this copy? Okay. Yeah, this works. Is the... Yeah, okay, the comments are a bit stale. How is this fucking thing so small? Wait, I meant to paste the whole element. Thanks. Yeah, thank you. Okay, it's good to thank people because gratitude is cheap. Okay, now we can move on. Yeah, we need to figure out... Okay, we'll change this to a line chart. And then add a button to add some elements into it. Let's see, how could that be done? Okay, let me just erase this table. Updated the comment. Okay, now we have this training charting. We'll add a button. Okay, the slot will fit. And okay, let's do SL button. Not bad. Click equals this add data. This doesn't need to be protected. I don't need the change properties. And add data. So, okay, so we can probably mix multiple series here. Let me just do a little test. I don't think we even need the x-axis here. Whereas with the JCharts, I mean with Chart.js, we... I guess we do need the labels. Why are these frameworks so fucking anal about the labels? Okay, never mind. Let's go into the documentation for this library, and we'll figure out how to actually. Okay, here are the docs. Chart container. ECharts instance dispose. Now how to guides, basic line. I guess this doesn't have a tooltip. How do we add stuff to the data? Series, data type. It can also be two-dimensional. Line style, green, width, dashed. I mean, the documentation for this is pretty good. I think it's more true than for Chart.js. 0, 20, and then the dash. It uses the dash to represent null data. I mean, couldn't they just put in null? Okay, dynamic data. jQuery set option to fill the data. Data. What's this? Data categories, data values. Where is the data coming from? Get data JSON. Done. So it set the entire options except with the data values. Okay, that's an interesting approach. I wouldn't have expected it. I guess we won't need to dispose the chart in any situation. Display empty access. It's empty at the start, and then okay, sales data. Okay, I kind of like this way of updating the data. It has a declarative flavor to it. So it does diffing automatically. I mean, what am I supposed to see in this example? So it's updating dynamically. Okay, this is interesting. Date push now. Okay, we're going to have to study this. This is a pretty interesting example. I just need to take a short break. Okay, I've had time to study for a bit. Over here, it first creates some initial data using this add data function. Then here it creates the options for the chart. As you can see, it's passing in the data here, which is an array that's first initialized here. And then it also has the date for the x-axis data. And over here we have a set interval function, and every 500 milliseconds, that is half a second, it adds a new data point to the chart and then updates it like this. Oh yeah, this is not bad at all. I mean, doesn't it have a tooltip anywhere? Let me try adding a tooltip. Tooltip. Oh, it seems like, and nothing is happening. We're not seeing any tooltips. Over here, yeah, we only had to set it like this and it worked, but suppose we did something like let's do this. I wonder if we are not seeing any tooltips because the chart is constantly being updated. At any rate, it doesn't really matter. So, what we'll do... Oh, it seems this is updating as well. I didn't notice because the chart is somewhat flat. Anyway, we have the dynamic data right now without the labels. I guess you can put in rich text in Apache ECharts. Okay, this isn't that important to me. Okay, never mind. Let's just move on. In fact, let's leave this as it is, so we can use it as a reference. Alright, how can we have multiple different series? Here we have the one series. Okay, suppose we did something like, let's say this. Would it still work? Oh yeah, it would. And suppose we added another series. Yeah, that still works. The interesting thing about this is that this series this series above actually starts where this one ends, because that's how we've defined the date, I think. Or maybe I was wrong, I'm not sure. Okay, but doesn't matter. Okay, we can very easily just do the series like this. I understand that now. ASD QA. Maybe it's simply stacking them on top of each other. Actually, I'm wrong. I think these two are in fact pretty much the same lines, except this one is like half the size of the one above. And maybe it's simply stacking them on one another. This area style. So it also puts in the area underneath. Okay, and yeah, we just have to dive in and do it. For the x-axis, I guess we'll just have to. We could just put in an iteration count, or we can put in the date. We can do a lot of things. And for the series, okay, let's do data number array. All right. Yeah, it would be much better if we could iterate over the arrays. Okay, let's make this a tuple of arrays. That's the easiest way to deal with it right now. And okay, how do we do a line chart again? Yeah, we just have to put in a type line. We have to put in the name. As for the data, we'll have to figure it out. Okay, let's do update chart. Const chart equals this chart. If chart in fact, let's just make this an immutable function. I want to feel like chart ECharts labels and data. The data will be number array, and the data will be what? I guess it could be a string. Let's make it a string array. And instead of just this being a number array, we can just make it a pair of string number. Yeah, no, not bad. Now it kind of makes a bit more sense what this is supposed to be, which is in fact, let's just I mean, can we not have inline types? String okay, I guess we cannot put in type definitions into the class itself. I'm getting a deja vu. I think we've already encountered this error at some point in the past. So, okay, here we have the type. And what? Yeah, we need to. Okay, data. And let's make it name string. And besides the name string, what you need is let's make it agent data. Okay, let me pause so I can think about what to name this. Let's make this Leduc train series. Just a second. I think I got an SMS on my mobile. I wonder if this is related to the hard drive that I ordered. Yeah, it's exactly as I suspected. 2 weeks ago, I ordered Western Digital Blue hard drive of which has 8 terabytes of capacity. So it should get here like who knows, maybe next week, most likely. And that will give me a place to put all these videos that I am making. Let's see. Okay, so we have the name. Yeah, we need the actual data, and that will be like number array. Okay, let's also make type Leduc train labels equals string array. Yeah, I like this. And this is okay, a bit more legible. Okay, let's do this at the top level. Update the chart. Const equals. So we have the chart, the labels, and the data. Okay, so what we now have to do is chart set option. What does this not merge? Lazy update. I guess I'll have to look into that later, but never mind that for now. Let's see, set option and x-axis data date. Okay. The first thing we have to do is make an assert that assert if labels length not equals data no, not this length, but it needs the data needs to be the same for all the wait, what the hell? Let's make this like so. And I want to make an okay, data every okay, let's do this. And yeah, this should this returns a boolean. If okay, if not equals false, determines whether all the members of the arguments satisfy the specified test. Okay, let's do this. Labels length equals x date. I mean, what the fuck did you do? X data. How many of these equal signs did I put in? X data length. Then throw an exception. Raise, or maybe is it throw? Yeah, it's throw error. The data sizes are not valid. Yeah, great. And now that we have this test, we can be sure that the data is at least in the proper format. And that really helps the readability of this function, because we are specifying the expectations up front. And this makes future programming easier. Now we know that, for example, that all the arrays in the refactoring series have all the data arrays have the same number of elements, and all the arrays have the same number of elements as there are labels. Now we can actually set the options for this. Let's see. X-axis data. Okay. X-axis data labels. And now we have the series. And this is an array, but we won't put an array here directly. Instead, we'll go over the data a map and we'll return. Actually, we need to do this double. No, not like that, but we need to do this. And in order to actually return a JavaScript object, we need to put it in parentheses. Otherwise, it will parse it as the function body. And okay, we need the name, type. Okay, let's do a name and the type. Name will be the X name. Type will be line. And data will be X data. Okay, I have no idea what these other settings are, but this should be good enough. Okay, not bad. And now okay, we have this update chart. We also have the chart. Okay, we don't need the x-axis, the y-axis, or the series. This is just to set the title and maybe enable the tooltip. We're also setting the resize observer. Okay, so now we'll do Okay, let's make the labels, and let's make this Leduc train label array. We'll set it like this, and we also let's make this series. Oops. In fact, we can do this a bit differently. Like, how about let's just omit this and then do X. Yeah, it's immediately more readable. Now, let's go back to this. Oh yeah, we need the series. Series, Leduc train series. And it needs... okay, how are we going to initialize the series? Well, let me just think about that. Okay, let's... okay, let's do this. Name agent1 data empty array. We'll initialize it like this. And now let's do something like okay, we'll get the current date, something like new date. Okay, let's make it const now. Value number. Okay, I kind of want to see how to get the current date. MDN date. Author independent integral number that represents milliseconds since midnight at the beginning of January, the epoch. New date. Oh, so these are not always equal. I have no idea. Okay, I won't bother reading this right now. Okay, get okay, for now let's just try out to get the seconds. And we have the new date. Now label push. Now get seconds. And we don't need to turn that into whatever. I guess we'll turn it into a string. And what we'll do for okay, let's go iterate series for each let's see, we need to actually push something into the data. Data push, and we'll push what? Something like math random. Oh no, how was it done here? Yeah, why not do it like this? This is not a bad way of doing it at all. It also considers the previous input. And if it goes past the end of the array, I guess we can just make it oh no, where is... Let me just start node in the terminal for a little bit. Node. And we have an array. And suppose we try... Yeah, if we index past it, we just get an undefined. And we can just use this to protect ourselves. Okay, so we have the math random plus 10. Okay, now we can, yeah, now this will add everything to the data. We also need to actually update the chart, and let's do update chart. Update chart. This labels. This series. And we only do the update if this chart the formatter works well. Okay, we can do it like this. Now it should have automatically recompiled. Of course, there's nothing here, and we need. We forgot to put. I mean, how we forgot. Okay, where the hell is the button? We cannot see it because there's nothing else. There, add data. Oh, it's not working. Y-axis 0 not found. Should not be called during the mining process. What the hell? I guess it needs an empty y-axis. Y-axis. What the hell? X-axis. Where's the y-axis? Okay, I guess we need the y-axis. How was it done? Oh yeah, I mean, it was pretty much empty like this. Okay, never mind. Let's take a look at some of the other examples. I mean, okay, let's just put something like boundary gap 0.50. I have no idea what the hell this is supposed to mean, but x is okay. Let's set some data manually. Data series type line data 1, 2, 3. We also need a name. Okay, and this works. Suppose we tried commenting this out. Suppose we tried commenting this out. Yeah, now it's complaining. Suppose we did this. Okay. So I guess this is the proper initial setting. Oh, now, yeah, we can actually try adding the data now. Okay, I've had enough fun. And yeah, if we cover all the data points, we actually see the labels. Agent 1, Agent 3. Yeah, this is very nice. Finally, we have the basic grasp. Oh, now what I want to do is actually initialize this properly. Or rather, that was the plan with the other library, but with this one, we're in fact just setting everything right then and there. So let's do this. Add item. Label. Series. Yeah, I think I understand what I want to do here. First of all, we'll do the basic const basic chart equals for fuck's sake, why is this? Actually, you know, yesterday I said that I hated this keyboard, but actually that's wrong. It's a very good keyboard. The only problem are these tiny leg things, and they fucking get unglued, and it's really a problem to keep moving the keyboard around. So I'm going to get a mouse pad for the other one. You know, I just wanted to apologize because this is a very good keyboard, but the designers made a mistake on just one tiny thing, and it kind of ruins the experience for me. But of course, the keyboard is far from being unusable. It's definitely a lot better than a regular keyboard. I think this design might be the perfect design for a keyboard. Like, I cannot think of another way of doing this, of designing a keyboard that makes more sense than this. They did an especially good job with the thumbs. Let's move that over here, and then we'll just assert the chart data. Labels series, and we'll also duplicate that and move it where here. Yeah, okay, labels. And then now I'm feeling pretty good. We have to do another assert here, and that assert is to make sure that okay, let's do this. First, we'll assert that for fuck's sake, doesn't JavaScript have an assert? Okay, we could just use console assert. Yeah, why not? Console assert. That having said, I'd rather it to just to enter an exception. We cannot use this in the browser. The length of the labels rate does not match that of the series data. Whatever, we'll just go with console assert. Who cares? Arguably, this isn't really a good solution to everything, because throwing an actual exception gives information to the type checker. But if we are factoring it out in a function, it get the same issue. But you know, I really want to see an error in the console instead of this sheet. Okay, let's do a const assert. Condition. Okay, text. Boolean string. Okay. So we have this, and then if cond equals false, then throw error text. And could we just put this in a utility library? Let me just make utils.ts here, and we'll put the assert here. Throws an exception with the conditional. Okay, never mind. Import assert from utils. Why is this giving me trouble? Frontend details is not a module. I mean, oh yeah, maybe we need to export it. Export. Ctrl+Shift+F. Let's see, now we have the assert, and this is a lot cleaner way to write this for me. We are asserting that the chart data is valid. Now, what we want to assert is this. This series. Actually, let's just assert this series length equals series length, and the length in fact, better than I said, I don't actually want to assert this. This is just the first condition, cond c1. Const c2 equals, now what we have to do is go over this series for, every x, and we also need the index, and I hope this is the index. Yeah, it is. And now we have the x name, and it has to equal the series y name. And if these two conditionals are true, then we can just update the series array normally. Let's see. Yeah, we just got to iterate over this series for each. Okay, this series for each, and x name, let's see, no, not x name, but x data push. Maybe we could even do extend or append. Is the push the only thing we can use here? What about join is for strings? Whatever. Let's use push data. Yeah, this is perfect. Else, we're just going to throw away the existing labels and the existing series and make a new one. Let's do like a label. This label equals label. This series equals series. This labels equals labels. And what we are doing here in essence is diffing the inputs. And if they're of the right format, we just add them to the existing arrays. If they aren't, we just get rid of the old stuff and put in the new stuff. So we can just get rid of this completely. I'm not sure whether it's right to do this in an immutable fashion like this, but it's fine. Now we also need to update the charts. Update chart. Oops. Update chart. Let's just do update chart. Update chart. Update chart. This update chart. Yes, okay. Yeah, now because we're doing diffing here, we don't have to worry at all about initialization. We can just get this chart and then push the items to it without any issue. So let's see. The data. Of course, now this won't work anymore, so we have to come up with something else. Let's see, update chart, add item. Update this add item. And okay, I guess we'll add only a single label. Like this. And for the series, okay, let's do agent 1, agent 3. Okay, let's yeah, we have to actually we have to put in the parentheses so we can return an object, and the name will be, well, the name, and the data will be yeah, but now we don't have the access to the previous element anymore, which isn't very nice. Okay, how about we in that case do this? At random. Okay, this series. But now it might end up indexing into the undefined thing. I guess this could be a weakness. Whatever. let's just put in random numbers instead of Ctrl-Shift-F. Let's just try running this. I guess this is a pretty slow video. And now if we add the data, why is it not adding the data? Are we getting some kind of exception? The length of the labels already does not match that of the series data. Really? Wait, what the hell am I doing here? I guess it should be in add item. Update. So this happens in update chart. Okay, let's do log, and not this, but a console log, and then labels series. It seems like it's getting printed twice. Agent, yeah, whatever. $45. I mean, what's the problem here? There's only a single label, but there are two data inputs. So, yes, that's not right. And is that the item not adding the items properly. Add item. Aha, yeah. We also need to this labels, push labels. And this kind of graph is lacking the nice uptrend that we had before. So, okay, where is the add the data? Let's rename this to add test data. And yeah, I kind of wish we could get. I wish we had the thing from before, even if only just to get the names. Name. We'll do this series. This series map. And then X. X name. And data. Plus X data length minus 1. Yeah, nice. I wonder if there is something like last index of no, I guess it isn't. There isn't. Okay, never mind. So yeah, I think I'm finally happy with how the graph works now. It took a while, but we did some utility functions. I still have no idea what this shit is supposed to be. Boundary gap 50%. I mean, the chart feels a bit different now. for some reason. I'm not too sure why. Oh yeah, it's much more. It's much taller. Whereas before it was. As you can see, the previous one had a lot of more space between the midpoint and the top, but this one doesn't. So it kind of feels squished. And chart control tax. The way this chart control is going to work is that it's going to simply pass this labels array and the series into it, and it's going to update the chart immediately. We won't have to worry about passing the wrong data and initializing it simply because we're doing this diffing. You can do a lot with diffing. Pretty much the Spiral's language server is based on this technique. It feels maybe feels like overkill just to get a chart, just to not have to worry about initializing the chart. But it's proper programming, I think. Now we won't have to worry about the initialization state in any other place. We'll just be able to call this add item thing. I guess. Yeah, we don't need this. Okay, so we have the chart. Now, I feel like taking a break so I can think about what exactly I want to do next. I guess what really motivated me for this is if we had something like a logging system and like a message box, we wouldn't necessarily want to care about initializing it or the data that's coming into it. And the same thing applies to this chart here that we created. So that's why we did this design. The only real requirement is that the labels match the series. That's the only requirement is that the data be properly formed. Yeah, let me pause here. I guess this is good work. What did I do? I mean, I just removed this. Okay. I'll be back soon. Let's resume. I want to say this. Common tasks shouldn't be underestimated. The video that you're watching now is already 4.5 hours long, which is like a quarter of the GADT video. But the only thing we've done so far is put a chart on the front end. So yes, it's not to be underestimated. Now, okay, let's get rid of that shitty button. We'll forget about the test data. We don't need that return type annotation. We don't need this either. Yes. This thing won't be a top level component. Wait, didn't I factor that out into a chart? This is a different component. Oh wait, maybe I shouldn't have gotten rid of that. Okay. And now, what I want to do is make the backend, and let's assume that the purpose of the backend is to produce these lines on a chart for now. Maybe we'll do a larger network of something like 128 ensembles and see how they compare against the random player. That would be a good first step. Like we want to optimize them, but knowing which agent in the ensemble is better than the other is the first step in making the evolutionary algorithms work. Leduc train UI. Okay, Leduc game. Okay, let me just think about this for a bit. Let me also raise the table. Static main routes core. It's in namespaces. Here's the Leduc game. I guess I'll make a Leduc train. Oh, Leduc train. Hi. Leduc. Let's make this train import main. Parallel game equals main. Leduc train. UI state. I guess it'll have event loop GPU, message state, game state. So it has the game state and the UI state, and the UI state is what gets emitted. At this time around, maybe we'll also have effects. Okay, never mind that. Let's also routes core main. Look. So we have this from game Leduc train. We should just focus on getting the backend into shape. Let's see, what exactly do we have here? We have a bunch of tests. Okay, let's leave this as a learn. Learn. I kind of want to start from scratch with the train. And oh, here we have the game. Yeah, we don't need all this shit. Instead, game state, UI state. I mean, we're even serializing the game state. We don't actually need to convert the game state into the JSON format. We could have left it as is. We don't have the init. Oh, this is annoying. Okay, what do we want to do first? Because the complexity of this is pretty overwhelming. Why is the notepad folder open? Oh, why do we have an error here? Do we have an error here? Add the test date. Let's get rid of the button. Now, how do we start off with this? Yesterday I said that we'd have public and private states. This is there's no more functionality, and so there are no more errors. Okay, what we have to do is maybe let's go back to the front end. We have to start somewhere. It's kind of difficult to maintain the motivation. Leduc train. Can I fold this in? Okay, great. I can. Annotate the chart. Assert data. Okay. Now we want to think about what kinds of states the UI can be. At the very start, when the frontend is loaded, the backend should be in an uninitialized state, and the neural network model won't even be allocated. So what we have to do is make the uninitialized state first. In which format were... Oh yeah, the union types were structured like this. They're a pair of a string tag, string literal for a tag, and then the second part of the pair is the actual data. Okay, so the UI state, let's... Oh yeah, it needs to be a pair. Uninitialized. And this will be unit. And okay, great. We have something we could call the UI state. Now, of course, it should start in an uninitialized state. Thank you, type checker. Wait, do we still have the console log? For fuck's sake, I still have this on here. We don't need it. Not bad. I guess we'll leave the sockets for later. Socket IO. And the styles from the parent overwrite these two, which is the behavior that we want. Training chart. But how will we update the training chart even if we get something here? Never mind that for now. Let's just do a switch on the state. Switch this state 0 case uninitialized. Let's tag this state tag. Okay, so yeah, now we can return HTML. Return let's put in no. Let's make a div. No. The model hasn't been initialized. Let's see. Did it? Yeah, I think it crashed. Yes, the model hasn't been initialized. And it wouldn't be bad if we could, have some kind of a text box where we can input the number of iterations we want to train. And then once we actually have some data, put in the chart. Okay, we don't have to care about the chart right now. Okay, let's take a look at the Shoelace stuff. Shoelace style. Like, can we do something like a format date, format number? SL format number. So, how do I use this kind of control? It's nice. Format number, SL input, type number, value, label, style. Okay, I see. Okay, let's take a look at SL input, and that's just the input. Input. We need a lot of those. For labels that contain HTML, use the label slot instead. Field text. Oh, nice. Placeholder. Clearable. Oh, I see. Toggle password. Type password. So this password toggle is responsible for this icon at the end. Field inputs. Disabled. Sizes. Pill. Email number. Oh, how does the number? I'm just wondering, is it possible to restrict the ranges? Type name menu. Link, max link, trigger expression. Minimum value and then the maximum value, so it has that. It has step, auto capitalize. autocorrect, autocomplete. I'm just wondering, how do forms work in Shoelace? Customizing the... yeah, how does this... SL input, SL text area... I mean, do they not have something like, you know, regular HTML form? What was that example? Form data serialization. Oh, so it has form. Min-max. Oh, I see. So it uses a regular form. Input annotation required. What's that? What's this? Custom elements when defined. Form data object. Oh, so you can create a form data object from any form. That's actually very nice. So the submit event is on the form itself and not the button. Yeah, I mean, I simply don't feel like fucking implementing. We're going to have a bunch of controls and maybe a button just to start the training. I don't feel like having to gather them manually and do the changes, do the bindings for the changes. Check coming before submitting. This is regex. It only allows words, I mean letters. Okay. Okay, forget it being initialized or uninitialized. And this can be empty for the time being. Much like it was before. We don't even need the state. And we also put in the training chart as it was here. But now what we also do is put in something like a form. How does it look? Class input validation required. Okay, let's see. SL input. SL input. It seems like we haven't imported it in the index. Let's see. Input now I have the input. What are we missing? I guess we need to give it a name. The minimum number of inputs, that should be 1. The maximum, I guess, doesn't matter. The step should be 100. And the type should be number. Number. Button, SL button, type, submit. Submit equals, wait, I meant to do this on a train. And how do I do the train? Ctrl+Shift+F on train. Submit event const data equals ev data. Just a second. We should import this, but for now, let's just extract the form data. Maybe we can query selector. Oh yeah, we just need to serialize the form. Okay, so let's do this. Let's do that. Okay, log AV target, and this should be the form itself, and the serialize HTML form element, and we are passing it event target. Submit. Yeah, let's do a label. Label equals number of iterations. It doesn't have to be like capitalized. Okay, let's check out what the DV target is. I think it should be the form, but I'm not completely sure. It hasn't been initialized. Oh, this ends up restarting the fucking EV prevent default. Now what are we getting here? Oh yeah, this is the form. If we target instance of HTML form element, then perfect. You should also really give it a default value. I guess we could set the minimum to a 0, and then value equals like 1000. Ethers 1000, and shouldn't this be a number instead of a string? Why is it putting a string here? Input. The fucking font size here is so damn large. Okay, suppose we didn't want to put in a form because it's kind of shitty at serializing. What else would we use? I guess we could do a property type number equals 100. Maybe change, or maybe input. This iter's equals x. What? This should be an event, I think. Input event, this iter's, and this is the input event, data, maybe parse int hundred. Oh yeah, it doesn't need to be a string because the serialization function doesn't necessarily know whether this input form will be empty or not. So that's why it returns it as a string. But going to do this pretty much everywhere is so annoying. Because now we have to bind it to a property. I mean, this might not necessarily be a bad thing. Okay, let's do these iter's here. Let's just put it right below, and it's not changing. Maybe change. Change event. fuck's sake. I mean, it's been a while since I did the front-end work, and now I forgot pretty much everything. Change. So we have SL change and SL input most likely now. For fuck's sake. Okay, let's see. Input. This will change, this will change. EV any. EV target value. X target what? Shift F. I. Let's put a break here. PR. And now, yeah, now the thing changes properly. I mean, is it easier to do this or to just get a different form? I suppose if you want to use the properties somewhere else, it's better to do it like this. Now, what was the difference between the form, the change and the input event? Change versus input event. Yeah, it's better to use the input event rather than the change, because input reacts right away, but change only gets fired when you remove the focus from something like a text area. Yeah, I remember this being an issue. X target value. Oh my god, this is such... Maybe we could just put in this iter's or parse int x target value. Yeah, it could also be parsed as nan. I forgot about that. And can we just convert the nans to like some sensible value? Or this pairs. Suppose we did this and refreshed. Yeah, this is the way to parse. Yeah, it's kind of a pain in the ass to how to do this, but here we are. Now, okay, the number of heaters. I want this to go from top down, not like this. Flex direction should be column. Yeah, this is a lot better. And the font size here is so damn large. I mean, it's fine for the tabs here. I want those to be large, but here it's super large. And let's check out the index to see whether we can do something about that. Lock height 100%. I mean, did I do that in global styles or? Did I do that here? Yeah, I set the font size to 30 pixels. If I remove this, what happens? Yeah, now the font sizes are a lot more sensible. And for the tab group, can I actually increase them? Like, let's see, where is the index.ts? Here you have the tab group. I mean, we also need to increase them for the other games, I think. Leduc. No, let me hold them. How do we increase them? I mean, we can just do this. I think this should at the very least increase. No, I didn't for the tabs. I knew this a few months ago when I was doing it, but now it's faded from my mind. What if we put it here? What would happen then? Absolutely nothing. I think it's using root font size to measure everything. Could we? Yeah, there's something about the class sizes. Let me just think of let me take a look at the output and the CSS. Let's see, UI backend and oh yeah, let's take a look at the bundles, and here we have the index CSS, and here it has a ton of these shoelace things, and SL font, SL spacing. Yeah, here we have the SL spacing, and it's using rem everywhere. And SL font size, can we use the SL font size 2x large? Suppose we took this and put it in like maybe No, not here, but class equals absolutely fucking nothing again. Class equals
Okay, this is like for me the worst part of Shoelace.
You know, maybe if you're a front-end expert and doing this day in and day out, you'd understand how to do this quickly, but I don't. S on tab. Tab active. Maybe we need to put it on the tab panel. I have no idea. For now, let's just put it on a single one. Okay, let me pause here so I can think about how to actually do this. I remember messing with this like when I was importing the Shoelace library the first time around, and I saw, you know, some styles and it was possible to toggle them, but right now I have no idea what's going on. I'll be back soon. Okay, I figured it out. Instead of trying to mess with font sizes, we could just put this stuff in a header. H2 H3 okay, H4. Let's do H4. What do we do? Yeah, it's not good at all. It has too much margin and padding. What about? I mean, does this library have anything for regular text? Something like typography, SL, font sense. Okay, we can make it a span and then just give it something like font size SL large. Okay, let's do that. Let's make it span class equals oh wait,
I think I understand. I don't, this is inside the DOM. I mean, inside the shadow DOM, so it cannot react to the top level to these top level styles. Wait, how did they get it to work in the library itself? I'm kind of confused about that. Okay, so how about suppose we did this like span and font size var, and then do we need a quote around this, or is something like this fine? Oh great, it did work. Okay, let's make it a B, like for bold. Yeah, this is not bad. Let's just make it a tab. I still want this to be a span, and span with a class of tab. For fuck's sake, how many times am I going to do this? Span class. And this is why it's so annoying to edit HTML. We have this, once we change the class here, we have to change it everywhere else. Indentation sensitive syntax is definitely superior to this. This kind of syntax is really made for machines and not humans. Why is this so bold? I thought it was, you know, bold because oh yeah, now it's finally doing the same thing. Yeah, great. We have everything that we need. I'm finally happy with how this looks. And as for this, the font size is a lot smaller now, but I'm fine with it. I don't care too much. Now we have the number of iterations. Who knows, this is a bit too wide. But whatever. I mean, we don't want it to pretty much to take up the entire screen, so okay, where is it? We can close this. And I didn't actually know that the variables are supposed to be used like this. This is a way to actually have inheritance in even though we're using the shadow DOM. So it's a new experience for me.
I'm not really an experienced front-end developer by any means. I'm guessing somebody experienced could do this a lot faster than me, but it doesn't matter either way. It's easy to get experience in front-end development. It's not the hard part of programming. So if you are incompetent, it can become hard. I've realized something about web development from working with, I wouldn't say other people, but another person. While web development is considered easy by good programmers, you shouldn't take that too hard, because it's hard to actually be a good programmer. So it's actually difficult when you take it on average. And you know, it's web development is like 40 times more popular than all the other programming activities combined. All the jobs are in web development. So, but it doesn't necessarily mean that it's easy. Like, you're just using the browser to create a front end, and that's pretty much the only difference compared to other forms of programming. You're treating the browser as your front-end framework. Okay, so what I'm trying to do is, okay, SL input. SL input with feed content. Once we do this, what do we get? Yeah, now it's using a lot inner size. And it's better for it to be this way, because I don't have to reach all the way to the end of the screen just to get to the font. And you know, if it's too small, it's very easy to just zoom in. I'm going to get rid of the padding in this, because 50 pixels is too much. Maybe just put in some left and right padding. Let's see. This is for all four corners, and if the left is button omitted, is it the same as top? Okay, so maybe 0 and 50 pixels. Let's see, is that it? This is then 0. And this is, okay, what if we did like 20? Oh, really? Why did the setting it to like, let's say 10%? Ah, 10 pixels. Okay, 0 and 50 pixels, and that's what we want. And yeah, the problem is that I put in a comma here. Okay, that's a bit nicer. Now we have the number of iterations, and the only thing we need after this is to maybe put in a button so we can actually start the training. So let's do that next. Oh my god, how much effort this is. Okay, we don't need daters here. Okay, let's do SL button, train, SL button, variant equals primary. And I guess we'll do something like submit, a click event. Click equals this on a train. Well, over here we should send something to the backend. Let me just raise the table. I have one train here already, never mind that. And let's finally put in this IO thing. I mean, do we have any kind of UI state to begin with? And even listener, game. These are the game events coming from below. I did this custom event, and we have the game events. Okay, never mind. We don't need this right now. And the UI state should always be our empty record. And in addition to the UI state, UI effect, and then update graph. And now this will be a bit different. Let's see. Leduc train serial, Leduc train label. Yeah, perfect. Now we have this update graph effect, and we have to actually do something about okay, here we'll be getting UI state, UI effect. Oh, let's make this X and whatever, X0. This process effects X1. This won't be a property. These effects will get processed right away. So let's see. I'm just using a pattern that I noticed in languages like Elm, and we also used the similar patterns in Fable back when we were messing with that at the start of the F# web dev series. And the basic idea is that you have the immutable state propagation, and you also have these mutable effects that you execute. And you kind of, from the view function, I think you also return, or was it from the, I forgot from which function was it. I think, yeah, from the update function. You return the new state, and you return a list of effects. And then, yeah, should be an array of effects. And then the effects get processed in a separate way, so they don't interfere with the nice functionally pure construction of the UI. Okay, so L UI effect array, and now we only have like a single effect. So okay, let's do the const tag data equals L, and actually L for each L, yeah, like this. And then now we'll switch on the tag, switch tag. JavaScript doesn't have pattern matching, and neither does TypeScript, but but at the very least it has a very good type system. It's not really as convenient as the one in F# or Spiral, but it's quite powerful. You can do good programming in it. What I've seen, unfortunately, when I looked at libraries, is that people abuse it too much. They use pretty much all of its power, and that tends to complicate the code a lot. They should stick to first order logic as much as possible. Update graph, and then we have this. Yeah, we need a break at the very end, and we should update the graph. And now we finally actually need the graph. I guess create ref, and that would be the graph. I mean, that would just be the training chart. And we'll ref graph ref. Oh yeah, we need to put in this. Now you have the reference to the graph. And now we can have the graph ref, and we'll get its value. And we'll update. We'll call update chart. Actually, no. We'll add add item, and now we have the data. We'll just put in the data like this, I think. Yeah, and it's fine. String array Leduc. See, yeah, perfect. And this is the way I envisioned processing of effects, at least for the chart. we cannot really pass the data from the properties because the chart is like an imperative mutable object. But we can add, we can mutate it like this. We might end up having a lot of data in the chart and having to really, transfer too much of it over the network card would be a burden. So I want to optimize this ahead of time to just pass the data into the graph as it comes as an effect. It's much like writing into a file. Suppose we're writing into a log file. I wouldn't want to literally keep all of it in memory first and then rewrite the entire file on every update. Instead, it makes a lot more sense to just append to the log file, doesn't it? Okay, so we have the ID. We have this update graph effect. Okay, let's also default assert what I'm looking for is assert. Yeah, assert tag is never. We want to put that into the utils function. I mean, we could probably move all of that into the utils function. I mean, file. Export throws. Yeah, I don't really feel like filling the comments for all these. It's okay, here we have the details, and we need to import from utils assert tag is error min max clamp. What the hell? Wait, what did I do? Oh yeah, I meant to put it here. I don't need these two events. Okay, assert tag is error tag. Case. Oh, oops. Okay, so it's like this. We might be adding different kinds of effects in the future here, so we'll name this like so. And we'll name this something like add graph item instead of like this. Graph add item. Oh yes, this is not bad. Okay, the UI state, instead of having the iter's property here, it should be in the UI state, because we're going to have to send this. We're going to have to send this to the backend, so it knows how many iterations to run for. Training iterations. $100 is going to be this by default object. And now we have to think about this a bit more. This state and iters, it needs to be training iterations. This state training iterations. And we might have other options here, so we'll do this. And this is how we do an immutable update of objects in JavaScript. Yeah, it does take a lot of time to set up the front end properly. And there's no way around it. Okay, so here we have the we have the UI state. We're going to be sending that to the backend. We have no reason not to. Now, when we click on train, we need to send an event. So let's think about that. We have heads up, no limit, hold them, and how are we sending events to that? Let's take a look at all the uses of socket. So it's looking for game events, and it's just emitting it to the update. Okay. So let's put that back in here. Maybe we should have some. Okay, let's add the event listener for the train event. We'll emit an update. We'll also have train events. Okay, let's make some train events. Type train event. let's just make it train, and we'll pass in the UI state. Yeah, this is good enough for now. Okay, let's make it plural. Why not? Now, how are these events raised? Oops. Raise, create event, dispatch event. This dispatch event. Okay, let's do train element, extends lit element, train events, train. We'll just have it inherit from train element instead. And what we can do, let's see. Now we should be able to, dispatch train event. And when we click the submit button, we just dispatch train event. Now we just do train here and pass in the UI state, this state. And at the backend we'll try to catch this and then do a bunch of training. And then it will send the UI state back and it will send the effects. Yeah, this should be good enough for the front end. Good enough for the front end. Now we have something to target. Okay, so what exactly do we want to do next? I mean, I'll probably leave it for tomorrow, because who's going to program this anymore? But even so, so yeah, the no limit content gain gets the message, which in this case can only be the train event, and then it also gets the game state. In this case, it will be the model, the neural network model. It will initialize itself. No, yeah, we should initialize the model in this init function, and we won't be converting the in our case the private state to JSON, because we won't even be able to do that, because it the arrays are going to be CuPy arrays. So how can I possibly convert that to a different format? We can't. In fact, if we look at the JSON M serialize, let's see, core Python JSON M. Okay, this is deserialize. But at the very end, it will complain that the object needs to be the right primitive type. Oh, and in serialize, I guess it needs to be, it can be any kind of object here. But if we deserialize it, union type, numerical type, case float, assert is instance xt. Alright, we can also serialize pretty much anything here. It will just check that it's the right type. Oh, in that case we can in fact serialize CuPy arrays without issue. Yeah, no, not bad. I guess the old design is right. I have no reason to go against it. Leduc train. Okay, let me just close some of this. So we'll be making the init function. The game state will have a neural network model from here on out. The event loop, I guess it will deserialize the training state and the message. But we cannot just serialize the game state to GPU memory blindly anymore. Yeah, I think I'm going to stop here for today because I don't feel like programming anymore. You know, I know I've been missing the early morning sessions and I haven't been doing much in the afternoon ones, but this is a really boring part. It's like 40 degrees in this room and I want to play reverse collapse. So there you have it. But you know, even if you cannot do as much as you want to usually, you just need to keep putting like 4 hours, 5 hours, and eventually the results of that will accumulate through the bottleneck. Couple once I finish this game and I'm very close to the end, I should be able to put in an extra few hours a day. And right now I'm busy with going to the beach and so on, so yeah, it's important to enjoy life, even if your life is just playing video games. Ideally, maybe I'd get a reply from some of those applications that I've been making, but I doubt that will happen. I've been making these videos to prove my programming skills, but nobody really cares about programming skills right now because there are so many fucking amateurs applying to everything that nobody has the time to evaluate anybody. I think there needs to be a crash in the programming job market before things get better. Eventually, the amateurs will get washed out of the field and things will get back to normal. Until then, we can just enjoy what we're doing right here. And when I say enjoy, I mean it's important to do programming in an enjoyable manner. You can get sick of anything by doing it too much. You know, it's one thing to say that, you know, I'll be doing programming for like 12 hours a day every day, but it's easy to get burned out. So it's important to do things in moderation. Lately, I've been enjoying video gaming like nothing else. It's been a long time since I did gaming last, and I got this new PC, and my RSI is getting better, so I've been able to enjoy myself properly. Yeah. I fear the future, and the only solution to that fear is to pursue the singularity. Even though I want money, I understand that money wouldn't get me what I want. The most use I could get from money is to buy bigger GPUs. But if I keep doing this, eventually I'll get them anyway. And this stuff here is great for my resume. Maybe I'll use it to apply to NVIDIA or something like that. You know, I've realized that the startups I've been applying to are a fucking joke. Maybe I should be looking to become a founder myself. We'll resume this tomorrow. I want to go have lunch. See you later.